Hello, we're going to talk about vector addition and an introduction to vectors. First, before we build onto vectors in Rn, let's understand what vectors in R2 look like. So for my linear algebra class that has had a lot of snow days this year, 2015, we have referred to certain matrices as vectors. So you may have had a vector on a project, a matrix on a project that looks like this, and we may have referred to it as a column matrix or a vector. So I hope that was not confusing, but we're going to start with the basic definitions now. So let's see, vectors in R2. So vectors are objects that have direction and magnitude. So graphically we represent them with a directed line. So we have, an initial point to our vector. Usually when we draw vectors, we start them at 0, 0. And the terminal point is where the coordinates x1, x2 meet. So the initial point is here, the terminal point is here, where the arrow points to. Now, the same vector can be placed starting at 0, 0, or you can move this vector around as long as it has the same size and the same direction. You can draw it anywhere you want, and it's still going to be called x1, x2, or whatever these numbers are going to be that we would choose. So in written work, we're going to use an arrow on top of the letter that represents our vector. In your textbook, you're going to see vectors. The vector notation is a bolded letter. So since I can't do bold on the board, we put an arrow on top of these. Now, the way we add vectors in R2 is we add the components. So, assuming that this vector u has components u1, u2, vector v has components v1, v2, we're going to add the x components, and then we're going to add the y components, and we get the vector for u plus v. Now, this is going to be useful. This notation will be useful when we prove properties of vectors in theorem 4.1. Okay, so useful notation for theorem 4.1 in our book. Okay, so let's use an example. So of course, here if you have vector u to be -1, 2, vector v to be 2, 3, of course vector u plus v is going to be -1 plus 2, 2 plus 3, and so we get 1 and 5 to be the resulting vector. Now, the way we add vectors graphically is as follows. So first, I'm going to draw my two vectors, my vector u and my vector v. So u, the x-coordinate of u is -1, and the y-coordinate is 2. And so, where -1 and 2 meet is going to be the terminal point of my vector, and my initial point, I'm always going to start with 0, 0. So this here is my vector u. My vector v is 2, 3. So on the x-axis, I go to 2. On the y-axis, I go 3. So this guy here is going to be my vector v, which has coordinates 2, 3. Okay, so now if I want to add these vectors, what I'm going to do is I'm going to translate this vector v, and the initial point of vector v is going to go to the terminal point of vector u. it has to have the same size and point in the same direction as this guy does. So that means starting here, I have to go 3 up and 2 over. So I'm going to have to go higher than this. So this would be 5. Okay, so from 2, I go 3 up and 2 over. So let's see, 1, 2, 3 up, and then 1, 2 over. So I'm going to try to make it as parallel as possible to there. Okay. So this here, we should see it as parallel to vector v. And it's actually vector v again, placed in a different spot. So now, the sum of these two vectors, or the resultant, as you call it in physics, is going to be the vector that connects the initial point of u with the terminal point of v. So initial point of u with terminal point of v. This is the resultant, or the u plus v vector. So this is how we add vectors graphically. Now let's see, where does this end? Where is the terminal point of vector u plus v? So the terminal point of vector u plus v is going to be at, let's see, we went from -1, we went 2 over, so the x-coordinate is going to be 1. And from 2, we went 3 up, so the y-coordinate is going to be 5.